Tēnā koutou katoa. Thank you very much for having me here today. As we've heard already, climate change is arguably one of the most fundamental issues of our time. Over the past century, we've experienced warming, sea level rise, increasing extreme weather events, which are attributed to human influences on our climate system. Climate change is likely to place unprecedented pressure on our environment, economies and societies over the coming decades and centuries. So we can thrive in a changing climate, we first need to understand what we may be faced with. This presentation, as you've already heard, will be provided to you as a bit of a Climate Change 101 that you can take back to your boards and executives. If we're all informed around the potential impacts of climate change, we can be better prepared and understand better for this different future. So how did we get to this point where human-induced climate change is such a significant global issue? Concentrations of greenhouse gases like carbon dioxide in our atmosphere directly impact how our climate changes. Greenhouse gases trap infrared heat from the sun in the atmosphere and stop the heat from escaping, causing warming. The graph on the top shows the relationship between carbon dioxide and temperature over the past 400,000 years. You can see that on the right-hand side of the graph, the recent rapid increase of carbon dioxide is unprecedented during this period. In fact, current carbon dioxide concentrations are the highest they've been in over 800,000 years. Changes that we are seeing now and expect to see over the coming century usually take thousands of years to happen. We are in unprecedented territory and there is a lot of uncertainty about what will happen when climate changes this fast. The recent increase of greenhouse gases is primarily due to the burning of fossil fuels like oil and coal since the Industrial Revolution, as we well know. You can see the bottom animation shows high concentrations of carbon dioxide in red and yellow being emitted from some of the most industrialised parts of the world. You can also see that our atmosphere knows no borders, so the human impact on our climate is well and truly a global issue that demands a global response. Higher concentrations of greenhouse gases like carbon dioxide and methane cause our atmosphere to warm faster, with consequences for global rainfall patterns, extreme weather events, changes to ice sheets, ocean warming and acidification, among other widespread impacts. We have been seeing evidence of human-induced climate change since about the second half of the 20th century. In New Zealand, our glaciers lost 38% of their ice volume between 1962 and 2018. That's enough water to fill 164,000 Olympic swimming pools each year. We've measured a 20 centimetre rise in sea level since 1900, with an acceleration in the rate of rise over the past few decades. We're experiencing more extreme hot temperatures and fewer cold extremes, including more common marine heat waves. 4 of the past 6 years have been among our warmest on record in New Zealand, as you can see on the graphic here, with 2016 being the warmest on record and 2018 being the second equal warmest. Extreme events such as deluges and droughts are getting more severe because of human-induced warming. Unfortunately, we don't have a crystal ball that can tell us what our future climate will be like, so we use computer models to understand climate change under a range of different scenarios. Our future climate depends on the trajectory of global greenhouse gas emissions, and we don't know for certain if they will continue at current rates, a so-called business as usual approach, or whether there will be a concerted effort worldwide to reduce emissions. This presentation mostly contains projections of the business as usual scenario, for simplicity, otherwise known as RCP 8.5, which is the red line on the 2 graphs on the slide here. The top graph shows future greenhouse gas concentrations, and the bottom one shows the projected global temperature change, both out to 2100. The climate change modelling we do at NIWA is used by the Ministry for the Environment, local government, businesses, iwi and other researchers to understand future climate change impacts and projections in New Zealand. Considering those scenarios of greenhouse gas concentrations, we may be faced with quite different futures depending on which path we take. By the middle of the 21st century, both the mid-range and the business as usual scenarios have similar temperature projections of around 1 to 1.5 degrees of warming compared with the 1990s, or about 2 degrees of warming above pre-industrial temperatures. This one you can see on the left-hand side. The left-hand map shows the mid-range scenario, the business as usual scenario, but the mid-range scenario is also similar to this at 2040. However, by the end of the century, you can see that these scenarios diverge considerably. Warming under the mid-range scenario in the middle map flattens off. It's about the same as it is at 2040. But the business as usual scenario on the right accelerates to about 3 degrees of warming by 2090 above the 1990s levels, or about 4 degrees above pre-industrial temperatures. The Paris Climate Change Agreement limits global warming to about 2 degrees above pre-industrial temperatures, which is approximately equivalent to the mid-range scenario. However, we're currently more on track towards the business as usual scenario. These temperature changes may seem relatively small, but Earth's ecosystem holds a delicate balance. About 55 million years ago, average global temperatures were about 8 degrees warmer than present. But palm trees and crocodiles lived inside the Arctic Circle, and the poles were free of ice. During the last ice age 20,000 years ago, global temperatures were only 6 degrees colder than present, but sea level was 120 metres lower than today, and 25% of the land surface was covered by ice. There will be many more hot days or days above 25 degrees, particularly in the North Island. The left-hand graph, or the left-hand map here, shows the historic baseline of the number of hot days, and the right-hand map shows hot days at the end of the 21st century under the business as usual scenario. A tripling in the number of hot days is projected for many parts of the country. Auckland currently experiences about 20 to 30 hot days per year, and this is projected to increase to 90 hot days per year by the end of the century under this scenario. Consequently, New Zealand will experience declining numbers of frosts. Much of the North Island and coastal South Island is likely to be frost-free by 2100 under this scenario. In terms of rainfall, increasing westerly winds driven by large-scale atmospheric circulation changes means that it's likely to get wetter in the west and south of New Zealand and drier in the east and north of the country, as you can see on the left-hand side. So many of the already wet parts will get wetter and the dry parts will get drier. In particular, winter shows a strong signal of increased rainfall in the West and South Island in particular, with up to 40% more rainfall experienced there in the winter. For much of the country, the number of days with rainfall is likely to actually decrease, leading to longer dry spells and potentially more drought conditions. So we can start thinking about what climate change means for business. I'm now going to focus on the physical climate change impacts for 3 different sectors: the primary sector, infrastructure, and tourism. For the primary sector, warming poses both risks and opportunities. More pests and diseases may cause issues for the sector, as winters will be warmer and new pests may be able to survive in areas where they are currently limited by temperature. The maps on the right-hand side show the changing suitability of New Zealand's climate for the Queensland fruit fly over the 21st century, under a mid-high end scenario, with the climate gradually becoming more suitable further southwards, as you can see by those red and orange shades. However, on the flip side, as a positive, the growing season will be longer, and there may be opportunities to grow different varieties of crops in new locations. Warming will likely cause pasture production to increase for much of the country, particularly in the central North Island and much of the South Island. Pine forests are also likely to grow better in a warmer climate across most of New Zealand. However, these increases may be limited by water availability in areas that might be more drought prone. Kiwi fruit, as an example from the cropping world, require chilling in winter to promote flowering. With ongoing warming, the number of good and marginal production years may reduce in northern parts of the kiwi fruit range, such as in the Bay of Plenty. The yellow and brown shades in these maps show areas with high numbers of good or marginal production years. Hydrogen cyanamide is a chemical that is currently used to increase productivity of kiwi fruit by increasing the level of flower development in warmer years to the level of development seen in cooler years, so continued use of this chemical may retain productivity as the climate warms. However, if the chemical is unable to be used in the future for whatever reason, kiwi fruit may become less viable in many northern coastal areas, as you can see on the third map on the screen. However, as you can also see, the number of good or marginal production years increases in the South Island compared with present as the climate becomes more suitable for kiwi fruit there. Drought risk is likely to increase across most of New Zealand in the future, particularly in the east and north of both islands due to reductions in rainfall. However, increasing temperatures cause more evaporation and water use by plants, so drought risk may also increase in areas where rainfall is actually not projected to change that much. Drought is likely to put increased pressure on water resources, with demand for irrigation at times of low river flow likely to be more of an issue. With drought comes increased wildfire risk, causing problems for the forestry industry in particular. Now moving on to the infrastructure sector. Extreme rainfall intensity is likely to increase with ongoing warming because more moisture is held in a warmer atmosphere. These increases will be particularly apparent in rare short duration events like intense thunderstorms, but we will also likely see increased rainfall intensity during events like ex-tropical cyclones. Increases to extreme rainfall are likely to have a significant impact on New Zealand's infrastructure, with the roading network more at risk from floods and slips, as well as coastal erosion and storm surges. This is the Waiho River Bridge down on the west coast earlier this year. Sea level rise will also have a significant impact on the infrastructure sector, as a lot of services are located near the coast on low-lying land. There is expected to be an additional 30 centimetres of sea level rise by around the middle of the century compared with the 1990s level, and remember we've already had about 20 centimetres since 1900. And about half a metre by 2060 at the earliest, depending on which scenario we take, and about 1 metre by 2100 at the earliest, also depending on which scenario we take. So that's under that business as usual scenario. Sea level rise will continue for at least a century or so due to lags in the ocean system compared with the atmosphere. Sea level rise causes coastal erosion and flooding, as we know, and saltwater incursion further inland. This saltwater incursion may affect pipe networks and other infrastructure that are close to the coast. A recent study under the Deep South National Science Challenge looked at the exposure of different built assets to coastal and river flooding in New Zealand. This graph is just one of many, but it shows the kilometres of roading exposed in different regions under different levels of sea level rise. You can see that the length of road exposed increases considerably with ongoing sea level rise. On average, national road exposure increases by 133 kilometres for every 10 centimetres of sea level rise. Canterbury and Waikato have the most road exposed, with over 500 kilometres exposed at 1 metre of sea level rise. The third sector I'll cover is the tourism sector. Sea level rise and coastal erosion will have impacts on tourism through damage to coastal attractions like walking tracks, affecting accessibility to these areas. Ex-tropical cyclone Fahey severely damaged parts of the Abel Tasman coastal track in early 2018, washing out bridges, tracks and a campsite. Storms like this may become stronger in the future due to warmer oceans surrounding New Zealand, allowing storms to retain their strength as they travel from the tropics south towards New Zealand. They might retain more energy and be able to have stronger winds and larger rain rates. Like the infrastructure sector, sea level rise and heavy rainfall events causing slips and flooding may also cause issues with the roading network, affecting how tourists are able to move around New Zealand. As I mentioned before, New Zealand's glaciers have lost a significant amount of their volume in the past few decades, and this retreat will continue. This will result in further changes to our iconic snow and ice landscapes that so many tourists come to New Zealand to experience. The ski industry will also likely be affected by more variable snow seasons. There are many unknowns about the impacts of climate change on New Zealand's native species, but it is likely that there will be negative impacts through changes to food availability, habitat suitability, and so on. Predators may increase their ranges due to warmer winters, pushing native species into marginal habitats. However, as a positive, tourism businesses will likely take advantage of opportunities provided by the changing climate. Before the 1990s, the lake at the end of the Tasman Glacier didn't exist, and now there are boat tours that take tourists close to the ice. There is evidence of climate change adaptation in the tourism sector already, with ski fields like Cardrona near Queenstown diversifying into mountain biking during the summer. So how can we adapt and thrive in a changing climate? As we've heard already today, from a business perspective, climate change needs to be treated like you would treat any other risk. However, unlike others, this is a risk that will likely have relevance for all parts of the business. Yes, climate change will pose huge challenges to our way of life as we know it, but there is also huge potential to do things differently. Business can lead the way in this space, and it's a great opportunity to be flexible and innovative. We must work fast to change the way we do things in order to have a more climate-friendly future. But I'm hopeful that we will overcome these challenges and we will live in a better world because of it. I just want to quickly talk about the climate change risk assessment that Vicky mentioned earlier, as NIWA is one of the partners in that in the assessment. So, as Vicky mentioned, the MFE is undertaking the National Climate Change Risk Assessment and will be undertaken every 6 years. It's an important first step in safeguarding the well-being of New Zealand into the future in the face of uncertain climate change risks. And it will provide an overview of how we're being affected or we may be affected by climate change and the risks and opportunities this brings, as well as any gaps that need to be further considered. And it will also inform the forthcoming National Adaptation Plan. It's framed around 5 domains. We have the natural, socio-cultural, economic, built and governance domains. And it commenced in September and will be delivered by mid-next year. And we want people to be involved. So if you'd like to be involved as stakeholders, please get in touch. There's an email address at the bottom, or you can come and talk to me at afternoon tea. A quick plug. But yeah, that's all I have to say. So thank you very much. And yeah, this presentation will be available to you as well as the speaking notes. So yeah, thank you.